Morning, everyone. Oh, everyone's really cheerful for 8:15. This is great. So, what I wanted to share with you all today is a bit about what is Visual Studio Code, but a little bit more broad than that. Why does it even exist? What's the motivation behind creating an alternate to Visual Studio, a lightweight editor version? We've had some really interesting stuff happen over the last 12 months. We had Satya announcing that Microsoft loves Linux and that the .NET framework was going open source, and a bunch of other really, really cool announcements. And Visual Studio Code is just part of this entire movement. One of the things that Satya keeps talking about is every platform, every developer. It's sort of their tagline that they're going with at the moment. And Visual Studio Code is really part of that. It's a cross-platform, lightweight code editor. Visual Studio, obviously you can't have every developer if you only have Visual Studio because it only runs on Windows. There's a lot of developers on Mac and Linux. There's all these other ecosystems. With Windows Azure, or Microsoft Azure, you've got full support for Linux and hosting Node and all of these other frameworks on Linux and Windows, and it doesn't really matter. It's all about let's include everyone. So let's just recap what's happened in the last year. We had .NET open sourced. That was pretty amazing. So now Mono can start pulling across different .NET implementations, improving the cross-plat story. We've seen Office be released for iPhone and Android, which is better than the Windows equivalents. It's about bringing all of these people across. Doesn't matter if they're not on Windows. It's about using Microsoft services and tools and all of these sort of all the related things to the ecosystem. You've got Xamarin and Cordova really enabling a great cross-platform mobile story. You can develop your application once and deploy it to all of these different devices. Cross-platform.NET. When this was announced, that was kind of a pretty cool moment where, whoa, we're actually going to be able to build apps in .NET using the awesome tooling that we know and love, and then deploy it to Linux. It's a pretty exciting time to be around. There's a cross-platform now open source. VS Code was open sourced this morning at the Connect event, which is awesome. So we've got a cross-platform lightweight code editor. This means that now we can start including all of these developers on different platforms. And we also had Visual Studio Community Edition. Free version of Visual Studio, pretty much professional, just some licensing differences. So in terms of what's happened in a year, the .NET ecosystem has just completely changed. We still have the enterprise story and the full .NET framework, but there's this entire stack of alternate tooling and different ways of working starting up. Today's going to be all about trying to give you guys, share a bit of my journey of getting some of my open source projects running on .NET Core, showing you how Visual Studio Code helps with that. There's three main areas I'm going to touch on. First is Visual Studio Code. We'll dive in, have a look at it, show you some of the features, how it works, what it's really there for. Going to dive into this core CLR and explain what it is, how it works, what is this cross-platform story. We'll see how that all goes because release candidate 1 got announced this morning and I did an upgrade and now things are all broken, so we'll try and fix that together. And then talk a little bit about the new version of ASP.NET that is cross-platform, really, really lightweight, designed for this service world, I suppose, where we've got a heap of lightweight services running in the cloud. The full .NET framework is very heavy. The footprint of it, just to get Hello World up, really heavy. This new world, really, really light. So starting to take advantage of all of these lightweight cross-platform alternatives to .NET. At Connect, VS Code Beta was released, so if you open up, there'll be an update now, and the beta version of VS Code was released, and also you can now go on GitHub and it's completely open source, so you can start contributing to VS Code, which is pretty exciting. Well, what is it? The best way to explain is, on the far right, we have Visual Studio. It's an IDE, it's a full-blown IDE. The idea of the integrated development environment is everything is integrated in it. You open it at the beginning of the day, you can access your work items, you can debug, you've got a heap of tooling. So that's on one side. And then on the other side, we have lightweight code editors. They don't really have rich IntelliSense or these great features that we're used to. So the things that we get in IDEs, we get project systems, being able to open an SLN file, and it understands how to build it, how to run it. It just works, right? It understands your code. We get really rich IntelliSense. We get full debugging. We got build, like just being able to Control-Shift-B to rebuild our project, or F5 and it launches it. This is something that a lot of other communities just don't have. Wizards, being able to just file new project, scaffold out all this templating stuff. Designers, ALM integration, platform tools, load testing, it just goes on and on. They're massive, massive products. Whereas editors, they're really small, they're lightweight, they're extremely fast, they open almost instantly. They just work on files and folders. You don't open up a solution in Sublime or Atom. You open up a folder, and then you work on all the stuff within that folder. Because they're so lightweight, they support a bunch of languages. You can, if you open up Atom and you go to the extension gallery, it supports every language under the sun. It also supports any workflow you would like. You don't have to be locked into the way Visual Studio does it. Because of the heaviness of an IDE, they have to restrain the types of workflows to basically align up with what's in that IDE. And they tend to be really keyboard-centric as well. Not so much mouse and keyboard, really quick to navigate and get what you want done quickly. So VS Code sits across to the left-hand side. It's about there, and it's a bit of a mixture of the two. Its goal is to be really lightweight and fast, still work at the folder level, but if that folder contains a project, well, I know it's a project, and I'll load up the context around that. We can still have many languages out of the box at the moment. It supports C# and JavaScript and the new versions of JavaScript, ES6, and a couple of others. Very keyboard-centric. We'll see that when I demo it. And the language it does support, it has very good code understanding. You get full IntelliSense. So you get this lightweight code editor, except you get the same sort of IntelliSense that you get from Visual Studio. And that's all powered by Roslyn underneath. We get debugging. I can hit F5, and just with a few bits of configuration, it can actually launch my application, even if it's Node or if it's a .NET project. It'll launch it, attach the debugger, and you get the hit F9 to set a breakpoint, and then you can F10 through to step over. But then it has also lightweight task running. So if you're using Gulp or Grunt, one of these Node build systems, it understands that. If you're using the DNX or the new version of .NET, it has commands. If you're using NPM and scripts, it understands those. So it has a lightweight task runner system that's nicely integrated. So it's more on the editor side, but it brings some of these nice features that you lose when you move to, say, Sublime or Atom or Brackets. Just a show of hands, who actually writes stuff in Node.js? And then put your hand up for if you use Atom to develop. Brackets? Sublime? Cool, a lot of Sublime people. All of those editors, they have the same sort of experience. It just, if you get auto completion, but it's based on text matching. So Visual Studio Code gives you that next step up. The other cool thing about Visual Studio Code is it's built on this ecosystem of open source stuff. So the first one is Electron. GitHub originally, they released Atom, and part of Atom is they released Atom Shell. And that was the desktop app component. And the idea is that I can write a web application with the full power of Node.js, but deliver it in a rich desktop application. And that's what Atom Shell was, which got renamed to Electron. Those of you that use Slack for desktop or Atom, there's a number of different ones that do it. They are all built on Electron. So Visual Studio Code is actually all web technology, and it's built using Electron. It's using Squirrel for automatic updates, which is another GitHub open source project. If you have the pleasure of using Click Once, I'd have a look at Squirrel because it's a much less painful alternative. And they're using FirstMate and TextMate syntax bundles for highlighting, which means that the same code highlighting and stuff that's used by the community can be used and lit up inside Visual Studio Code. As I said, it was built on web technology. Electron allows you to actually build it using web technology. All of VS Code is written in TypeScript. It's really, well, not all of it. The editor side, we'll see how the architecture works pretty soon and how bits of it can be written in other languages, but the main bit you interact in is all TypeScript. This means that JavaScript runs everywhere, which means Visual Studio Code can run everywhere. The Visual Studio Code is not, the editor is not actually a new thing. It's been around for a little while. You just might not have realized that there's this product being moved around. And it's called Monaco is the name of the product. The first time we saw it was actually from the Office team, was something called Napa. So in 2013, Microsoft released a new add-in model for Office. They needed to do this because previously the only way to extend Office and SharePoint was sort of build these COM extensions, which you got loaded up in process. That only works on the desktop. What we want is we need a extension story for Office and things that's cross-platform. This is a really big theme for Microsoft. So the new extension model means that you can write your task panes and all your extensions in JavaScript. Napa was an online editor that allows you to just create a new Office add-in, give it a name, click Create, and then it will give you an editor with IntelliSense to actually write your Office add-in in the browser. That was the first time we saw Monaco on the web. The next one was Visual Studio Online Monaco, and the idea of that was, if I've got an Azure website, I can edit it online, click Save, and it will publish the updates. Once again, in the web, full IntelliSense, nice experience. IE11 actually uses Monaco as well for all of its developer tools. And each time Monaco got reused, it had to learn a bunch of new tricks. So because in Internet Explorer and web pages, you tend to have minified JavaScript and CSS and HTML, so you end up with these massively long lines of text. Monaco now had the ability to be able to wrap nicely and have good performance looking at these massive lines of text. Then OneDrive started picking it up and using Monaco for its editing. This taught Monaco internationalization and being able to show and edit using a wide variety of languages and such. So each of these things just pushed Monaco a little bit further, allowing it to evolve. Visual Studio Online introduced its new, in 2013, introduced this sort of new web portal that's been growing and getting much, much better. The diff experience on there is all powered by Monaco. So now Monaco has sort of learnt to do this nice rich text diffing and display all of that really nicely. So each of these has just evolved it. So then the logical step was to, well, let's make an editor with this. And using Electron, they could bring that amazing web-based editor onto the desktop, give us a real nice lightweight experience. But that's not where they stopped using things from the community. It's built on top further JavaScript support. The way it gets really, really nice in IntelliSense is it uses TypeScript. The nice thing about TypeScript is it's fully compatible with JavaScript. So you can execute your JavaScript using TypeScript, and the compiler can actually infer a bunch of nice information for you. And also, there's a repository with a bunch of type definitions, which allows us to essentially type JavaScript libraries. Visual Studio Code understands that, can pull in these type definitions, and then say you're using Angular. You can get rich IntelliSense with all of the method overloads, with rich documentation, all using the TypeScript language services. But we want to be able to edit .NET, right? So there's another project called OmniSharp. And OmniSharp was born from people wanting to use Vim and Emacs to edit their .NET applications. So OmniSharp originally was using nRefactory. Now it's built on top of Roslyn. And it gives us the sort of refactorings that we like in Visual Studio, and if you use ReSharper, a lot of those refactorings are starting to come to OmniSharp, so we can extract methods and rename variables and do all of those sort of things. So let's have a look at it. So this is Visual Studio Code. This is just an empty project. We said that it works on by files and folders. So I might clear that. Oops. So what we'll do is I'll just make a directory for us to work in. So I'll just call it my console app. And I'll open up a new instance of Visual Studio Code pointing at that. I want to use Visual Studio Code to show you the new .NET stack. Part of having a lightweight code editor, the project systems that we have are really quite heavy. We don't want to have, we can't just create a CS proj file by hand. That's just not going to happen. We're not going to code up an SLN file. So we need this alternate stack. So what we'll do is we'll start using this to just create our application. Actually, I'm doing the wrong demo too. What I'm actually going to do is show you the Node.js. So I'm going to, there was about half a dozen of you that have used Node.js, right? So what I want to do is, a lot of the paradigms in this editor and this world come from the Node.js world. So I'm going to use something called Express. It's quite similar to, it's a web host framework. So when you self-host a web application in .NET, Express does similar sort of things. So what we can do is we can go npm install. Node is very command line driven. There's no, the community uses these text editors. So we have NuGet in the .NET space. In the Node space, we have npm, the package managers. This is the way you bring down all of your dependencies. So I'll install all the dependencies there, and then I'll open up code. The first thing to note is we have a package.json file. This is the start of any Node application. It lets you declare the dependencies. It tells you where to start the application. If you go npm run, that'll load up the application. The version, the name, those sort of things. We then have the entry point. So that was under bin www. Oops. This is not, there we go. This is essentially what a Node app looks like. It's all JavaScript, and Express allows us to create a web server and then run it. So I want to just run this application. If I hit F5, Visual Studio Code doesn't know what type of application this is. It just is a text editor by default. But I can say that I want Node.js to be my debug environment. Because it knows about Node.js, it can read that package config and then generate you the debug configuration. This is the first sort of extension point. We're in the web, so we can actually just expand that. Whoa. So same as you can scale up the browser, you can do that in Visual Studio Code. So this is the first extension point, launch.json. You can teach Visual Studio Code how to launch whatever application you want. And this will become richer and richer over time. So in here, we're using Node, but you can also, there'll be different types of launch configurations and a bunch of other ways to do it. So now if we run this again, we'll notice we get a debug console, and suddenly it's the debugger's listening. I'll jump over and go to routes. I can hit F9 and hit a breakpoint in my different controllers, so to speak. These allow you to handle web requests, similar to MVC controllers. So I'll set breakpoints. I've got lots of tabs. I'll hit localhost 3000. That's where my Express app is being stored. Visual Studio Code is now telling me that it's hit a breakpoint. We can hover over things, get a nice state of the world. If we go into the debug tab, we can actually add watches, which is not very responsive. Oh, there it is. So I can actually just go rec. You can see here that it's actually got a type of incoming message. This is because it understands that we have pulled in the Express typing information via TypeScript, and now we're in JavaScript, which is a loosely typed language, but we're getting type information from TypeScript. But you've got all of this context, and we've got a stack trace and all the things that you would want from a rich debugger. I can hit F10, move to the next line. I can just continue on, and then my application is there just running. So that gives you an idea of how configurable it is. You can just hit F5, say, I'm doing a Node.js environment, and it will let you just continue. Any questions on that? Anything I can show you guys? Yes? The question was, can you edit and continue? I'm not sure, actually. That's a good question. We can find out. Because JavaScript is interpreted, not compiled, it will just work. It'll just continue executing and interpreting. We don't need to do it. Where that won't necessarily work is if you're using transpilation, like TypeScript, or you do have a transpilation step, it has to go through that. The other thing is there are global watches, so you can teach Visual Studio Code to, when these files change, rerun my build, detach and reattach, so they're on sort of the new version of the code. Edit and continue For .NET applications, not so much. But we'll see the core CLR changes that a little bit. Anyone else? Good? Great. So that was sort of a bit of an entry point into Visual Studio Code. You can see that by default, I'm jumping down to the console. I'm not creating new projects through the editor. I'm doing npm restore from the console, jumping back in. Restoring packages and these sort of things, they're not exposed by default in the editor. It doesn't give you that rich IDE experience. The idea is it should do one thing well, which is editing your code and being able to let you work with that code. One of the questions that people ask a lot is why Visual Studio Code? Why not just add really good debugging support to, say, Atom or one of these other projects that are out there? And Visual Studio Code actually has a different architecture. It works fundamentally differently to say, Atom. And this is because all of the language services and the debugging support is actually all out of process. Majority of things in Visual Studio Code do not live in the main editor. Atom, everything lives in the main editor. All extensions are loaded into the one process. So the way it works is you've got this tooling service architecture that Visual Studio Code exposes all of these different endpoints. And for the language services, you implement the contract. So Visual Studio Code can just ask your endpoint, give me IntelliSense for blah, and then you return that back as a JSON result, and it can show it nicely in the editor. So all the extensibility is all just done via simple JSON contracts. Same with debugging. It's got, for the Node.js or the Mono, they're both two completely different debug engines, but what Visual Studio Code can do is create a lightweight adapter that as you hit breakpoints, it's telling Visual Studio Code, I've hit a breakpoint. It can then turn that into a nice experience in the IDE. Because of this architecture, it's completely extensible. They can add more services over time, and we don't actually have to worry about this monolithic editor and, oh, there's a new language being released, or let's wait 6 months or for the next update to bring this out. Talking about that, also announced at Connect this morning, they opened up an extension gallery for Visual Studio Code. This was #1 on the list of requested features. Some of the extensions that are in there this morning is full support for Go. If anyone writes Golang, you can install an extension and you can get full IntelliSense and debugging inside Visual Studio Code. It's pretty cool. We'll just have a quick look at the extension gallery. So we're back in my Node.js application, and the next thing that's a really important part of Visual Studio Code is something called the command palette. So if I go Control-Shift-P, that will bring up the command palette. This is the way you get around Visual Studio Code. By default, if you Control-Shift-B, will bring up the command palette, which allows you to execute commands. But there's a bunch of other things that this palette can use as well. So if I go ? It'll give me context of what I can do with this. I might want to go to symbol, or when I get into .NET, I'll show this off. Or want to run commands. I want to do Git integration. I want to run a task. So the task runner is generic if using Gulp or Grunt or one of these node build systems, or if you're using the new .NET system, it has its own task runner and commands built in. Visual Studio Code can be extended to be able to just run any tasks. They're all just generic tasks to it. So this is the command palette. So the first thing we want to do is you've got the extension gallery. So we can go extension install. We can also quite easily hit that by just searching for extensions. I can show installed extensions or install one. So I'll say I want to install an extension. That'll hit the extension gallery. Then we've got a bunch of interesting extensions. Code snippets for Angular. That's backspace plus plus. But the one I'm going to have a look is the spelling and grammar check. So this was created by Sean McBreen, who's one of the PMs on Visual Studio Code. And I can just hit enter. I'll click, actually I might have already installed that one. So let's go install something else. Develop PowerShell scripts in Visual Studio Code. Cool. I'm not going to use it, I'll show off the spelling check one instead. But after it's installed, Visual Studio Code will give you a little prompt to say, hey, I've installed this. And then it's got to restart now. This is a great feature. Because it's a web app, we can actually just go reload window, and essentially that does an F5 on our entire editor to reload extensions. That just tore everything down and reloaded it in place. Pretty cool. So what I'm going to do is I'm going to create a readme.markdown. Visual Studio Code is also one of the best markdown editors. So if I go my readme, I can actually just switch to preview mode in line. Really nice reading and writing experience. And then you can just split across and do a preview on the right. And then here I can go, my spelling is terrible. And you can see that this is the extension. It's seeing that my spelling's terrible, and it's giving me suggestions of spelling and spewing. Cool. The key binding, the question was, what's the key binding for preview? It's Control-Shift-V. But what you can do is, if you want to discover what key bindings are, I can just search for Markdown Preview, and you can see there I've got Toggle Preview, and it tells me what the shortcut is in the command palette. So while I'm unfamiliar with the tool, I can use the command palette to find any command. It's got copy, paste, sort of any action that you can perform in the editor is exposed through the command palette. And then it will show you the associated key bindings. It's pretty cool. Any other questions? Cool. So that's extensions. Go have a look. So in terms of the other ones that I was saying, language services. I called out Go. That's full support for Go if you're using it. And there will be a lot of other support for different languages, and all of these services and languages are going to just be exposed via the extension gallery. So you can pick and choose and take what you want. So check that out. You can also go to, I think it's extensions.visualstudio.com, and they've got a nice extension gallery. You can also build your own. That leads me into, we now have seen Visual Studio Code. We kind of have an idea of what the editor does. I'll continue showing more features as we get into the .NET Core side of things. But this is the next logical step. What is .NET Core? What is this whole, why are they moving all my cheese? If those of you that have started playing with it realize that there's a lot of stuff moving. We're going to see that in a minute because all my stuff is broken. But first a bit about the motivation for doing .NET Core. The .NET ecosystem has started fragmenting. We've seen that with Silverlight. It had its own runtime, its own BCL. It had different API surface area to the full .NET framework. You have the Windows Desktop Framework, which has a massive app model, massive BCL and all of the libraries. It covers everything. And it has its own runtime. Windows Store, much smaller API surface area, has its own runtime again. Windows Phone has its own runtime, its own copies. The .NET code base has been forked in all of these different places, and it supports a different level of APIs in all of these different scenarios. And this is where portable class libraries came in. Well, we need to be able to, as a library author, write an assembly once that I can then deploy to my phone or my Windows desktop or whatever. So portable class libraries gave you that approach, different portable class library configurations expose different levels of API. So the less platforms you support, the more APIs you get. If you want to target the full .NET framework and use all of the rich APIs there, you can't take that DLL and run it on a phone. It just won't execute. It's using APIs that don't exist on that. So the core framework is designed to solve this problem. We want one .NET framework. We want one system.io. We want one system.threading. We don't want to have to fork that and make changes in multiple places. So what .NET looks like in 2015 is you have the full .NET framework that we know and love. And then we have this .NET Core that's being built up. At the moment, that's for ASP.NET 5, so sort of the new version of ASP.NET. We're going to start seeing the breadth of that increase. But the initial scope of it is we want cross-platform web apps. And we can do console apps as well. But we don't have cross-platform WPF, WinForms, and all of those rich client .NET framework stuff. They're not going to go cross-platform. Well, who knows, but I don't have that sort of information. So you can target either the full .NET framework or .NET Core. But what it enables is the base class library, all of these system threading and different libraries can be written for the .NET Core and broken up, and then that IL can be shared with the full .NET framework. You're not having this fork of everything. That also gives us a bunch of common stuff. So the runtime is mostly shared across these things. Roslyn gives us a compiler that can target both of these things. And the other part that's really interesting is the new .NET framework is delivered via NuGet. NuGet's been a part of the .NET ecosystem for a while, but it's becoming much, much more important. The .NET framework itself will be delivered via NuGet, which that opens up some interesting things. I no longer have to install the .NET framework on a machine. I can bundle the entire framework and all my dependencies up with my application and then just execute it wherever I want without installing the .NET framework. This enables a bunch of cool side-by-side scenarios. You no longer have, I've tested my app on .NET 4, someone goes installs .NET 4.5.1 on the machine. That's a global thing, and then it breaks my application. That's not going to happen in this new world. What it actually looks like if we dive into .NET Core is you've got a unified BCL for all of these different platforms now. And then you just have the specific app models for each of them. You then have different runtimes. Has anyone heard of .NET Native? Not too many. So .NET Native is a really, really cool technology that's been coming out. It's used currently for Windows Store applications, but what it allows you to do is natively compile .NET applications, which means they're not being interpreted, they're actually compiled down to machine code so they can be executed natively. With the full .NET framework, it couldn't unwind all of this. It was all tied in together. So part of this has been breaking up all of these libraries so then they can be shipped in individual NuGet packages. Everything here is shipped as NuGet packages. That includes the .NET runtime, or if you're using .NET Native, the runtime for that is shipped on NuGet. Allows you to just package anything up that you need. So everything is a package. This includes your applications. If you are creating class libraries and things, this new tooling, out of the box, you can just flip a bit and then suddenly you're creating a NuGet package. NuGet is becoming the format and you're not going to be able to get away from it anymore. Even the BCL, which we'll see in a sec, just you doing anything will be pulled in via a NuGet package. Part of this, I alluded to this before when I started the wrong demo, was the new project system. We can't create a CSproj file in an editor. It's not going to work. So we'll resume that demo that I was doing before. So we're back on my console application. Part of this new system is we need a new sort of project system. We can't use CSproj files. MS-Build doesn't work cross-platform. It's just not going to work for us. So I'll start off and I'll create a file called project.json. And I'll just start off with an empty project. What I can then do is I get IntelliSense like straight away with a bunch of different things I can do. So I'll start off and I'll just give it a version. I'll then say I want to target a framework. So what I can do is I can actually say net40 if I want. Or I can say, what is it? DNX Core 5.0 because I want to target the new core framework. Don't pay too much attention to what these are because these are all changing again in a few weeks. I think they've changed 3 or 4 times, so it's hard to keep up. But this will be changing to net standard 1 point something. Anyways, so we've got DNX Core 5.0, and that's telling my project that I want to target the .NET Core CLR and the current version's 5.0. So we've got .NET 4.6, 4.62, that's the full .NET framework, and then .NET 5 is this new Core CLR world. Version number is a little bit confusing, but that's fine. We'll learn. So we've created our project.json. I then want to go program.cs and open that up. So I want to create a console application. So I'll just create program. And then I need a public static void main. Before I was saying that we're using OmniSharp, you'll notice down the bottom, I've got this little fire icon and project.json. So OmniSharp has actually recognized that, this folder has something I recognize in it. It's a project.json file. This means I'm working on a .NET application. I'll fire up OmniSharp, and that's my context. So you can see here, public static void, predefined type system.void is not defined or imported. I've got nothing here. What I want is actually to be able to go console write as well. So I'll just jump into project.json, and here I can actually say I have dependencies. And in my dependencies, I can specify NuGet packages. So part of the IntelliSense is saying, well, I can have NuGet packages in here, and if I just control space, we'll go up and actually have a look on NuGet. So what I want is I actually want system.console. And then save that. When I save that, Visual Studio Code will say, hey, you've got dependencies that you haven't pulled down. Do you want to restore them? So I'll hit restore. That'll open a utility, which I'll jump into in a sec, which is similar to NuGet. It's called DNU, which will end up being most likely sunset for NuGet. Doesn't make sense to have these two things split. But for the moment, DNU restore pulls down all of these NuGet packages. Interestingly enough, if we jump to Jake and then DNX, can everyone see this up the back? Cool. So DNX has all of these packages. It has a shared cache across everything. So I've got a bunch of different runtimes. These are just on disk. There's a tool called .NET Version Manager, which can list the versions of the .NET framework that you have installed on your machine. You can have multiple versions of .NET installed at the same time, and then the one that has a star next to it is the one that you're currently using. You can see I've got Beta 8 here, and then this morning they released RC1, the final version that got announced overnight. When I upgraded to that, they've changed a bunch of ways that things start up, and another tool, which I'll show you in a minute, doesn't seem to generate the right thing. So I'm still on Beta 8 for the moment, just because I know that works. And changing what you're demoing on an hour before, don't recommend it. So we've added a system console here. We've done a DNU restore. And now I should be able to go console.writeline. We've got IntelliSense here, and not just IntelliSense, we understand the type system. So as I've typed system.console, we're actually getting all of these different things that if you're using ReSharper or one of these other tools, even Visual Studio 2015 with Roslyn, it understands your code and gives you some suggestions. So we can generate a local variable called console. I want to use system, but I can also change it to system.console, fully qualify, or I can generate classes. I can do all of this stuff. So I'm just going to go using system. I can then go write line. And I get nice IntelliSense, what you're used to in Visual Studio. I get all of the tooltips and the XML comments. They all come out. So system.com, write line. What I can then do is introduce the next utility. So we had DNU restore. That allowed us to restore packages. If I delete, when I do DNU restore, we saw that the frameworks were on disk. All the packages are on disk as well. So every package I've installed is actually sitting in this packages folder. I can jump into that, and you can see I've got the different versions of there. Because everything's been updated, I don't want to try my luck of deleting all of this stuff and showing you the restore. If anyone was in the Developer vNext session, the number of times my get went down in that session was quite annoying. So we've got console.writeline. The next utility we want to do is DNX. So DNX is the .NET execution environment. It is the thing that runs. It's equivalent to the way .NET used to run. So what happens when you compile your exe in .NET? It puts a little bit in the exe that says, hey, this is a managed assembly that the .NET framework needs to know about. So when you double click on that thing to try and run it in Windows, Windows goes, that's a managed assembly. .NET manages that. It boots up .NET and hands your assembly over to .NET, so .NET can actually run it. It's not Windows that's actually executing your application. DNX, because we don't have that, we don't have a global install, we can't tell the operating system, hey, DNX is this global thing. It's packaged with your application. So I go DNX, and then I say, might help if I'm in the right folder. So I can say DNX run, and then that's actually spun up the console and said, hi, Ignite. The cool thing is, that's actually cross-platform. So if I pulled that across onto a Mac, I could compile it and run it on a Mac or Linux. It's pretty nifty. Next thing I want to show you is introduce another tool that the Node community uses all the time. So I said that there's the Node package manager. Well, with this new world, ASP.NET, you've seen in Visual Studio, we've had tooling support for Bower, NPM, all of these different package managers. NuGet is no longer going to be the primary way that you get dependencies, especially for things like JavaScript. It doesn't make sense. NPM has huge amounts of packages, and it's moving so fast. But there's like Angular. If you go into NuGet and install Angular, it pulls it down from NuGet. Problem is, every time the Angular team release something, either I think John Papa is currently maintaining it, he's got to pull it down, repackage it into a .NET, a NuGet package, push it into NuGet, and then you can be up to date. Why not cut all of that out? So we're now using these other tools from other ecosystems. Most important one, and the one that I use a lot, I do a fair bit of web programming, is NPM. NPM lets you, is just the node package manager. So it allows you to install things globally. So what we're going to do is install something called Yeoman. And Yeoman is a tool that it's equivalent to the scaffolding stuff in Visual Studio. When you go file new project and you get all of these project templates, and then you choose one, you get a project ready to go that's named properly, the namespace is correct. Yeoman is the same thing, but for anything. It allows you to install generators, which are essentially templates. I'm going to cancel that. So I'll just run, okay, now it's uninstalled. I'll have to wait for that. So there's a bunch of different templates you can install. The one I've installed at the moment is the ASP.NET generator, and that's for this core CLR world. Well, this figures out what it's doing. Any questions? Was the question, does it have somewhere to see the errors on build? Yeah, I'll show you that while this is installing. Yep. Okay, I'll show this and then I'll do that. So if I mistype something here, I get the squigglies. If I try and build, it'll say there's no task runner configured. So what I can do is, this is the other extension point, tasks.json. It allows you to specify how things are built. So instead of TSC, I'm going to do DNX or DNU. And then instead of hello world TS, I'm just going to go build. If I now build, I get the output, and it should fail with a error somewhere. It still worked. So over here, it's just saying that console does not exist, or badly spelt one. I can then just see errors in my solution. So if I put an exclamation mark, it will give me all of the errors and warnings across my solution. I can then just hit F8 to scroll through them. Yeah, so if you're in a file, so I can use the command palette, open up, exclamation mark, navigate, and then I can just use F8 to go through all of the errors. So that's sort of how errors are exposed. The next question was, what's the difference between myget and NuGet? Myget is simply an alternate host for NuGet. So NuGet is the official feed that everything goes on, but myget allows you to stand up your own feeds. So in terms of nightly builds and things, all of the teams, rather than publishing a new package every time their CI kicks off into NuGet, which will slow things down, they can create their own NuGet feed just for their private builds, and then they also don't affect us. We don't want to see the fact that they're building all of these unstable packages, so it allows people to opt into that feed. So it's just the source of packages, essentially. Okay, so Yeoman's installed. So if I say yo now, it'll ask me, what would I like to use? The reason I'm not going yo ASP.NET is because there's bugs in Windows 10, then you can't actually select anything. But in here, I'll go, okay, I want to run the ASP.NET generator. So Yeoman will start up and say, welcome to the marvelous ASP.NET 5 generator. And it'll ask me what type of project I want. So this is pretty standard in the Node world. There's generators for Express, there's generators for Angular projects, there's generators for everything. They're just scaffolding templates, essentially. So I can say, I've got my console application, but for the moment, I want a class library. It'll ask me, what's the name of your ASP.NET application? Now this confused me, because it's asking me what the ASP.NET, but I'm just creating a package. All of this .NET Core stuff came out of the ASP.NET team. That was the primary goal, to get cross-platform .NET web apps happening. But there's a whole ecosystem around how do we build shared libraries across all of these different platforms. So we'll run that, go into our class library, say dir new restore. Great, that's all working. I can then say code dot, and that'll open up my console. So this is exactly the same as what we saw before, except we don't have a main method. It can't run. There's a convention that whenever you run a .NET Core application, it looks for a static void main method. And that's the same for ASP.NET. You have to create a static void main method inside your ASP.NET application, and then you have to call inside that into the .NET ASP.NET host and say, host myself as a website. This is a change that came overnight with RC1. Before that, it automatically sort of looked for a startup.cs project and bootstrapped that for you. You have to do that manually now, so it's a bit more explicit. But you can see my class library can target .NET 4.5.1, .NET 5.4, which is not that. I think that's supposed to have changed. These monikers are annoying. So DNX 4.5.0, and I'll restore that again. But I can also go net 3.5. So this is going to be any different targets. I want to multi-target this assembly. I want to put in what different frameworks I'm targeting. So I can then go dir new pack. Whoa. I changed things. Every time you change that project JSON, you have to run dir new restore. So I'll go dir new pack, and it's blowing up because system.threading doesn't exist. We'll do a dir new pack again. Oh, this is dir new pack. Let's go green. Yes. So that's created me a NuGet package in here, which has both targets, DNX Core and net 4.5.1. So you can declare all your dependencies and just say dir new pack, and it'll create your NuGet package. This is everything's becoming a package. They're making it much easier. Notice I didn't have a new spec. I didn't have to create that and then spec it up and make changes. It also allows me to do publishers where it includes the entire framework. So if I go dir new publish, it'll actually bundle things up. I'll just go dir new help. So what I want to do is I was saying that you can package the runtime with your application. In here, if I say runtime is active, and I don't want the source, that will actually bundle up the .NET framework as well into my output directory and give me a couple of batch files that I can just run, and that will spin up my application. It's obviously not going to work for a class library, but it would work for our console application. Last thing I wanted to show was a real MVC6 application, which I'm not going to be able to demo because this is actually broken. I could not get this working before. So we'll run ASP.NET. We'll give it a web application of Web 2. I've already done Web 2. Let's go Web 5. I really shouldn't have tried installing the RC stuff. So one thing about the release candidate that got dropped this morning, it actually has a go live license for production. So if you do want to use this stuff in production, it is now supported. See if you want to do that. Not so sure yet, but I'll hold judgment until I actually have time to actually fix my machine and give RC1 a decent run. So saying there's a magic startup.cs file, this has actually changed now. So previously, in the old templates, this line wouldn't actually exist, this public static void main. It just automatically said, okay, I'm a web application startup. You have to do that yourself now, and you say Microsoft Hosting, web application, run startup.cs, which is my application, which means I don't have to have a magic string class anymore. I can call it whatever I want. Few interesting things. Dependency injection is included in the box. So by default, we'll have full dependency injection. We also have this service configuration where I can add things into the pipeline. So add MVC, add transient email sender. So this is configuring things in the IOC container. You can also add like static files. By default, ASP.NET has no static files. It won't serve them for you. Nothing's included in the box. This is why ASP.NET 6 is so much faster, is because it doesn't do anything out of the box. You have to install everything. So I want to be able to serve CSS files and HTML files out of my site. I have to install the assembly, pull that NuGet package down that gives me the ability to serve static files and hook it into my MVC application. Now I can serve static files. Have a look. There's not much point. I'm running out of time, so and this is completely broken. I really shouldn't have touched it, so I can't even run this for you. I'm sorry about that. But have a play around, pull down the different bits, and start playing with it. It's changing a lot. There's an announcements repo that every time they break anything, it gets announced in there. Definitely start getting involved with RC1. So the previous release that I'm running against now is Beta 8. From Beta 8 to RC1, there's a heap of changes. Things have been renamed, things have been rename spaced. All the monikers have changed, which is like .NET 4.5 to DNX Core 5.0, and that'll then change to Net Standard 1.0 or 1.2. Once all of this settles down, which it should start settling down, like we've hit our RC, so most of the breaking changes should be in there, but there will be a couple more before it goes RTM. So that's a bit of a run around of the new project system, VS Code. Actually, there's one thing I wanted to quickly show you is in the command palette, if I do hash, I can actually just go index and I get searching for symbols, sort of go to symbol similar to ReSharper. So some really, really cool helpers in VS Code. That was something I meant to point out before. So that's the new project system. You've seen Yeoman, which is installed off NPM, jumping out of VS Code down to the command line, doing some stuff, jumping back. It tends to be, you're not in that IDE experience. You're using the tools that make the most sense. You'll start seeing this tooling being added to Visual Studio, though. If you do want your IDE, it's just console first, and then nice tooling is being built on top of it. So what I haven't shown today is the IDE experience of this. If you open up your package.json and add a dependency, as soon as you hit save, you'll see your solution start going, restoring. It's downloading and restoring those packages. You don't have to jump out, run dnu restore. The IDE is just doing all of that for you. Any questions? The question was, if I have someone on my team working in Visual Studio Code, I'm using Visual Studio, will that work? Definitely. So the idea is that there's another project type called Xproj instead of CSproj, because Visual Studio is really heavily reliant on this project system it has. The nice thing about Xproj is you don't have to list all of the files that are included. So one of the nice things we noticed, I didn't have to reference those CS files, they're just all included by default. Xproj has that ability, and then you exclude things. So you can open up your SLN, you have the Xproj file, which is for Visual Studio to give you that nice IDE experience, and then Visual Studio Code will just use the project JSON to edit in the file. So you can move between them, and it's just a matter of setting your project up so it works across all of them. I'm not sure of the context. So,
like if I'm using a TFS
yeah.
for a project.
So I think the question is around if you're using TFS version control, does it integrate with that? No, it has Git integration. But that said, there's an extension gallery now, so it wouldn't surprise me if the different source control vendors could plug into Visual Studio to give sort of a better experience. But at the moment, it's Git. I did a session on Git yesterday trying to convert people across. Git's amazing. Everyone should get on board. Yeah.
With Git, will it actually straight from Visual Studio Code upload like I'm using?
The question was, if I'm using Git, do I have direct integration? Yeah, one of the tabs in Visual Studio Code is Git, so it has native Git integration. You can commit and push from the editor. So, yep. Anything else? Cool. Up the back. The question was, how is Visual Studio Community different to Visual Studio Code? So Visual Studio Community Edition is essentially Visual Studio, the full-blown IDE, and the professional version of that, except it's licensed for free usage. Like, you can use it completely for free. It has support for extensions, which Express didn't. And it also meant that with Express, you had one for desktop, one for web, that sort of stuff. It's exactly the same as Visual Studio Professional, except the licensing says you can't use it for commercial use. That's the difference. And VS Code is the lightweight text editor. So. The question was, is there any integration with Azure? No, but Azure has all of the different PowerShell commandlets and that sort of thing. So the idea would be you'd put an extension in that would bridge the commandlets and expose those into the command palette. That would be the way integration would happen. So have a look at the extension gallery. I'm sure it'll come. It's break time, so I'll let everyone go. Thanks, and do your evaluations.